Let me share my screen. So did you guys able to figure out why the container is unhealthy? Have you guys able to figure out why the container is unhealthy? The assignment.
Ashok, I'm getting same error, Ashok, once again. I've deleted the ports and I've checked these two Docker log files.
We
This
gave
time,
that DB as Mongo only. We didn't. We took off that IP address that you had mentioned and made it internal connection. We searched many
Yeah.
videos and
I said why the container is unhealthy. That is the reason I said to figure it out. That was the reason I told you to figure it out, because why the container is unhealthy. Try today. Tomorrow I will explain if it is not able to
yes,
possible for
yes,
me.
Ashok. Actually, we both thought of asking the same thing. Like, if we are discussing about the assignment, we thought of asking you to give one more time, one more day of time, because we wanted to try it on our own. We actually got connected and we were trying from yesterday, Ashok. We watched many YouTube videos and we individually worked on it actually to see what
No.
actually is going wrong. Uh,
Yeah.
like couldn't actually rectify the problem. But okay, Ashok, we'll still try, Ashok.
At the time of debugging, are you able to learn new things or not?
Yes, Ashok. Actually, many things we are learning, watching videos and going through the stuffs.
That's actually good. Okay. What exactly we have discussed yesterday? Just give me a little recap. So, what exactly the Docker Composer problem was? Where there was no availability problem. Where if one of the container is down, we will means the application goes down. Means one of the container goes down. How we have to bring it up? We have to make again the Docker Compose run automatically. If it is a production based application and suddenly the container goes down, then that will be a problem, because we have to run manually, and at the same time the user will not be able to access the application. Scaling, we want to run multiple containers means hundreds of containers, but in a single machine you will be able to run as many containers as you want, but that will choke up your machine, that will choke up your EC2 machine. So where we are, the scaling is a big problem, because if the users are increasing, the users are getting increased, and we don't have the space to increase the application, the containers, so then that would be a problem. And other one, the multi-node challenge, where we are not able to keep, means if we are able to create 50 containers in a single machine, but that is choking up the EC2 machine, but we need to keep multiple, means we have to distribute the load on to other EC2 machines, where if the container is available, that is not possible with the Docker Compose, the multi-node challenge, it was not possible. And being in the production application, without stopping the application, without taking any downtime, we have to replace our application from the version v1 to version v2. It was not possible with the Docker Compose. It was not possible with the Docker Compose. That was the reason we came into the picture of container orchestration, where it's a container orchestration is automatically all about managing the life cycle of a container. Managing the life cycle of the container. What is the life cycle of the container? The three stages, the three phases of the life cycle of a container is: starting phase. What is the starting phase? The configuration phase, where the container name, image name, port mapping, volume, network configuration, and everything, whatever comes when before starting the container, it comes into the starting phase. The running phase, when once you started the container, how to scale, how to load balance, the availability, the health check, that is called running phase. The deletion phase, once you are done with your work and you want to do it everything, that is called deletion phase. This is the life cycle, means you can, it's just a pictorial view where we have just represented you. And the container orchestration, in the container orchestrations we have many tools, multiple tools, where right now Docker Swarm AWS Managed Services, ECS, Kubernetes, DigitalOcean, Redshift, and right now we are discussing about Docker Swarm. What is Docker Swarm is about? It is also a container orchestration tool, and it is a part of Docker Engine. It is a part of Docker Engine. It helps you to create, deploy, and manage all the Docker containers as a single virtual system. As a single virtual, how we will be showing it to you. And as I mentioned, the life cycle of the container, starting, running, and deletion, it manages both of the things. And the Docker Swarm architecture is manager worker architecture. Here the node is called a machine, means we node is nothing but a machine, and manager worker, where the manager assigns the tasks, assign the work, everything to the worker nodes, and it only manages the cluster level management tasks, cluster management level tasks. And the leader node, if you are having multiple of managers in a single system, means suppose you are having two managers in a single project, one will be chosen, in both of them one will be chosen as the leader, who will be the one assigning the task, who will be the one everything comes to him or her, the leader node. The worker node is the slave node. We actually call slave, where we are working for the manager. We are working whatever the tasks we are being giving to us. We are just providing, we are just completing, and we are doing the tasks. But the manager is the one who is actually assigning the task. And if you see the architecture, this is an internal distributed store where the internet is coming, and there are three managers who are, one of them will be chosen as a leader, and they are assigning the tasks to the worker. This is a pictorial point of view. Three managers and seven workers. So there are 10 containers. The 10 containers, three are managers, where they distributed the load, distribute the work, distribute the task between the workers. Now, how we exactly do? For that, let's create, we will go with the three cluster instances. I'm going to create three node, means three EC2 machines, and in the three EC2 machines I'm going to install Docker. So let me do that.
We will be installing separately, Ashok, for each Docker.
Yes, for first time, for the every machine we need installation, Docker installation for all the machines, whatever means machine, how many machines you're going to take, that many machines you need Docker. Okay, I'm going to take three instances. See, in a single go, I have created three instances. Let me go to the instances once. I'm gonna keep it as TWD worker one, and him as a worker two, and this as a master, so that it's easy to understand. Okay, now let me install the Just yes, now okay, now I have installed Docker in all the 3 machines. Okay, let me something so that the way it is easy to show you all the now we have three EC2 missions. Which one was the leader? Okay. Just the leader. Okay. Now we gonna see the commands how exactly the Docker swarm initiate. Now if you see the swarm, nothing but a cluster of machine and worker nodes. So now every node means every machine is having already Docker installed. Every machine is having Docker installed. So everything is already installed. So now what we're gonna do is that we're gonna initiate the Docker swarm. You don't have to install Docker swarm again because it's already a Docker engine. So it's already a Docker engine. So it automatically takes care of that one. So if you mention here Docker swarm, Docker swarm initiate address, advertise address. Advertise address, the IP. What is the IP of this one? 172.31.84.55. Why it is throwing the error? Just a minute, guys. Okay. What the hell?
Ashok,
What's my Ashok? Tell me.
is there any semicolon in starting from that, Ashok? Docker, semicolon Docker.
Oh, thanks, Ashok. So before actually adding this Docker swarm, let's do one thing. Here, you have to add the rule, because we are actually what we are doing, we are actually interconnecting, means these three clusters, means these three services are internally going to add one another, means internally they are will be communicating with one another. So we have to add this security group so that it doesn't have any issue. That way it will communicate each other inside when we start working on it. See here what it has given. Read the lines. Swarm initialized. Now the swarm has been added. Now this one, the current node, this is the manager node. Now this will assign the tasks to the next two EC2 machines. Now if we want to join them as a worker, if we want the worker to be added to this manager nodes, to add a worker to this form, run the following command. Run this following command. So we have to run the following commands so that it will join as a worker to this machine. I think I have to use sudo here because we don't have the permissions. Just a minute, guys. See, if I add, see, this node joined as a swarm as a worker. This is now joined as a swarm as a worker. Now for this one, see the now if you go here, if you go to your manager node and see Docker node ls, see now which one is the leader, which one is the leader, which is one is the leader. The leader will always be having the star. Now see 85 55, this is the one which we are able to see the low node as the leader. Now if you see here, what is the IP 71 857 57, see this one is also connected to the cluster. Now to this one, what is the one 49, What exactly here it is showing the 49. So all the three clusters now, are have been into the Swarm cluster. Now they are all joined as a worker. Docker node, Docker node ls. Now these are all the services. Means now the manager will be able to assign the tasks to the other three services. Docker node ls. The command should be docker node ls. This is the command which shows which is the leader, which is the workers, how many clusters are there. So we have created what exactly we have done. We have created three EC2 instances, and in the three EC2 instances, we have installed Docker in all three of them. And in one of the command, in one of the EC2 instance, I have run Docker Swarm initiate advertise address along with the IP address. Now this has given a created the manager node here. This machine became a manager node, and it has given a code, it has given a token, where it was given a token Docker Swarm join. That token we have taken and we have run in the other EC2 machines, so that this node become means this machine became a worker to this EC2 instance. These two became a workers to the EC2 instances. You guys understood what we have done up to now, right?
Yes, Ashok.
Yes, Ashok. Yes, Ashok.
So this is the way how exactly the swarm works out. Now, before moving it out, there are two things, Docker Swarm concepts. One, the task. First, there are two things, task and service. Task and service. So what exactly this task? The task is the starting phase of the container. The task in the Docker form, the task is a starting phase of the container. Means the container name, the image, port mapping, and everything. Whatever you provide, whatever you want to do in the container, whatever you want to define everything, that will be the task of the Docker Swarm. That will be the task of the Docker Swarm. The service, this is the running phase. Running phase of the container means what task to be executed on the manager node, what task to be executed on the worker node, how many containers has to means the manager will decide who will get the task, who has to be worked out. So to make sure how exactly this works, let's do one thing. Now we have to run a service. Now you guys tell me whether if I run this on the worker node, whether it will work or not. If I run this will work or not, you guys tell me.
No, it will not work, Ashok.
No, like
See,
the manager needs to assign it to the worker, so I don't think it will
yeah,
work.
now see, this node is not a swarm manager. Worker nodes cannot be used to view or modify cluster state. Please run this command on manager node or promote the current node to the manager. Means it is asking, I'm not the manager. Why should I do the tasks? Why should I ask be the project work who assign the tasks, who actually starts the tasks? I was not. Ask the manager to assign to itself, so that or otherwise promote me as a manager, I will start working on it. Means first, if you are going to start the service, if you are going to bring a project, you are a worker, you will be doing what? The working, only the tasks which has been provided to you by the manager. Directly you can't bring the project. The same way, first, if you are starting any service, anything, we have to start it from the manager. We have to start it from the manager, where he will be taking that, okay, this is the way we have to create a service. Means now if we create this service, see, the task is being created. Now the container has been created. What was the container? Docker service create name web server, replica s3 nginx. So we have got, where is it? Now if I do docker ps, There is only one container here. I have run 3 because I needed 3 containers. Now, if you go here and do sudo docker ps, see, it assigned one task to here. Now, it assigned another, means continuously docker service ls. If you click it here, it will not be having the permission. Sorry. Docker service ls. It will be showing, see what exactly it is showing. It has been created with the name web server. It has been having 3 replicas on the 3 sites. Now to check fully whether all the services are running perfectly or not, you can take this id or maybe the name, whatever you want. You can just docker service ps and print it. It will show what is the desired state, on which node everything is working perfectly or not, on which thing it is working or not. Now if you stop any container, now suppose if you stop any container, I am gonna just stop the docker. If I'm gonna stop the container, docker stop, I am stopping the containers. Now if I do docker ps, there is nothing, right? Docker service ps and the same container id, see it. What we have shut down, but see, it started it again. It started within a second. Once it has been down, once we shut down, it automatically created another container for our itself. It created another because we have mentioned that we needed 3 containers. So automatically it created. See, we got shut down, but it got created. It got created within once it got shut down. Because here we have decided that we need the containers to be 3. Now, if you want to delete all the service, means if you want to delete all the service, Docker service,
Docker service ps minus a.
no, Docker service rm of app server. Now this will delete everything. Now if you do docker ps, there will be nothing. Docker service ls, there will be nothing. So everything will be gone. If you want to see sudo docker ps, there is also nothing. Nothing. Now you can give as many services as you want. You can create multiple. You can create 10 services. See, if you want to see, I've given 3 replicas. Now I'm going to give 10. Now see how many replicas will be created, how many containers will be created. See, now if you do docker ps, see here how many docker containers here are running, 4.
Or
Now if you go here, how many containers here it is running, 3. See here 3. So means the manager has taken 4 nodes, 4 containers, and the other 2 nodes have taken 3. So that way it worked out. Now, in case if I stop any container, if I stop any service, let's show this. If I service ps, you can view the web server or the container ID, it's up to you. So the 10 are running. Now let me stop one. Let me stop, try to stop. Now if you do same thing, see, it will be creating another one. See, It got shut down, and within seconds, it got created another one. It makes because we needed 10 replicas, so that was the reason. That was the reason it was able to. It was able to create within a second. See, now, is there a chance that you can delete the service from the worker node, the same service? Is it possible?
From the service, it won't be possible.
From the worker,
Ashok.
sorry. See, as I mentioned, they have only view or modify. They don't have anything. They are just only view. Can't be used to view or modify. They will be only executing the task. So let me delete this here. I will just do only three because it is easy to explain. Okay. Now let me create the replicas with 10, 3. Docker service ls. So this is the way how you exactly create how many replicas you wanted, how many things you wanted, how many things you need to check. These are the basic commands. Docker node ls shows you how many clusters, means how many nodes are there in that single in this form. There we have mentioned, we have seen, we have created 3, so we have taken docker node ls 3. And service ls, it shows how what exactly means the replica. If you have run, how many times you have to make sure you have to be in there, you have to be, how many services are running. Docker service, the replica was 3, so it shows this one. And if you want to create a service, docker service create the name and how many replicas you want, and after that nginx, means whatever you want to run here, that name nginx. And docker service ps web server, this shows whatever you have created that service to inside, what exactly is happening, what is the running state, what is exactly is happening, what is the running state, and whether the services are running properly or not, how many uh, desired state, and what is the current state is going on, and what is the image and everything. Now if you want to upscale, if you want to upscale, you can do that. If you want to upscale or downscale, you can do that. The command is this one, docker service. You can do it. Now if I do 4, automatically another container will be created. See, one more is created. Now if you see docker ps somewhere, so it is not handled here, so somewhere it got assigned to some worker here also. It got assigned to here. See, automatically it got assigned to some other worker node. Now if you downscale, if you want to downscale, you can do that. See, it scaled to 3. Now it will be having each one only. So automatically here, whatever it was there before. See, now here it is having only 1. Before that it was having 2. So this way it makes sure, okay, whatever I want, I will be keeping that one only. Whatever you want to do, it will be keeping that one only. This is the way you can upscale or you can downscale how many services you want to run, how many services you can have to run. This is the command, docker service ps and everything. This is the command. Are you guys able to understand?
Ashok, That upscale and downscale thing, please repeat it, Ashok. I didn't get it. Like to distribute, we use upscale. Is it, Ashok?
Yeah, if you want to have more containers, if you want to have more containers, see, like here we are having right now only three containers are been running. Now I want to upscale. I want to create more containers. I want to create more containers. I have to distribute the load. I want to create more container. I want to distribute the load. Then I will make 5.
Okay,
And
instead of
here,
that, adding the numbers in replicas, we use this upscale.
see, at the first time when you are creating, in the first time that there is the thing you can decide how many you want.
Okay.
The service Docker service create command is that when you are first starting, this is the first time when you are creating the service, when you are creating the service for the first time. This is the first time when you are creating service and you needed only 3 containers at that time. But once the load got more heavy and you want to add a different container, means you want to add another one more container and have to distribute the load to a different container. At that time, you can use Docker service, the name, Docker service scale, the name of the service which you have started equals to how many you want. You want 4, you want 5, you want 6, you want 8, how many you want. You can provide this here. And if I'm gonna give 6, it got scaled to 6. Now the 3 containers will be got increased to 6. See, now it will be distributed. Here it has been distributed 2, means it got one more. Here it will be going to C. Here it got to increase to 2. Now if I reduce the scale, now my work is a little bit done. I want to reduce one container. I'm just gonna make it 5. Now it got scaled out. It got scaled out to 5. Now one more container would have been deleted. See, this one has been deleted. The manager itself means the manager assigned the task. So he decides whether who should go to which task, which one should be going, which node should be having the load, which node should be taking this load. So that way it works out. Till your doubt is clarified, Prashant?
Yes, Ashok. Yes.
Now, if I want to promote, this one of the worker nodes to manager, because I am maybe taking only, maybe I am not having healthy, I'm not being good, so someone has to take the task. So I'm gonna promote the node. I'm gonna promote the node. Which node? Any node, which any machine I'm gonna promote, so that I will be, the other worker will be act as a manager. Means I'm promoting the manager, I'm promoting the another worker to manager. Now the command is docker node promote the IP address. Docker node promote. Now I'm gonna promote this one. See, now it has been promoted to manager in this way. If you click Docker node ls, see, the 55 means the manager node is still the leader. Here now this has become reachable, means available. In case this leader is not available, I will be reachable. I will be the one taking the task. I will be the one who will be assigning. Now if I see, means the manager will be able to see. Now on this 49 we will be able to see all the other tasks. We will be able to print. We will be able to see sudo docker node ls. If we do now, we will be able to see all the things. Means the manager is also able to see what exactly is going on, what is exactly going on in the project, what exactly who is has been having the task, who is having everything. Here he can see docker sudo docker service, but he will not be able to assign any task. He will not be able to assign any task because he doesn't have the leader permission. Only the leader will be able to assign the tasks to the worker nodes or to the manager also. Now, suppose if I stop this one, this will take a little time, but if I run this command, systemctl stop docker. If I run this command before running, now here, if I stop this worker, means if I stop this worker, if I stop this sudo systemctl stop docker, means I am stopping the docker, I am stopping the docker on the node. Now on one worker node or maybe on the manager node. Now see what happens.
Here leader will be leader always, Ashok.
You can change it also. Once if the leader is been down, means if you stop the docker here, automatically the manager who is reachable will become the leader. I will show you. That will take a little time. That I will show you. Now if you do docker service ls here, where the replicas are 4, means we have provided back to 3, right? Now if you see on 57 it has been shut down because we stopped the docker. We have stopped the total docker. Total docker has been stopped there. Systemctl stop docker. Now in which, if here it will queue docker ps, it will not, because there will be no containers. Now the manager will be assigned that tasks. The manager will be assigned the tasks to some other nodes. Means it has been replicated here. It is been here. It has been given here. If you go to here onto sudo docker ps, see, it is having, because we have been mentioned that it needs to be transferred, it needs to be worked out, it needs to be having only three replicas. Now if we start here, if we start sudo system, automatically the docker considered okay. Now if I stop some container here, docker ps, where is it? If I stop, this will be created. The container will automatically created on the worker side. See, now it started running on the 57 again. It was not there before it got shut down. Now it again started running on the 57, 7 seconds ago. This is the way how. Now if the leader is not available, here, if the leader is not available, so I am running. You
Ashok,
guys,
here
yes.
IP address would be same and the ID would be changing, Ashok, every time we stop and run.
Yeah, the IP address is the same IP address, right? You can't change the IP address of the machine once it has been assigned to it. If you have restarted, means if you have stopped and started, means restarted the instances in the EC2, on the EC2, then the IP address would have been modified. But we are not stopping anything, right? We are stopping the container, not the EC2 instance.
Okay.
So if I stop here, if I stop this sudo system local, automatically this one, the 49 will become the leader. but this will take a little time. Just see that. No. Late. See, one has been, so automatically it will take it. See, the 55. Just a minute, guys. This will take a little time to come up. So that I can easily run this. Now see, who is the leader? Now see who was the leader.
It has
49,
changed.
49 became the leader because it got stopped. The Docker got stopped on the 55 machine. So automatically it has provided, means there is another manager. So the task, whatever it has been, it moved to the leader. It moved to the leader. Now, if I stop it here, so automatically the leader will again back to the this machine. This is the one, right? See, now it has been back to 55. This is the way the swarm decides who will be the leader and who will be assigning the tasks.
Ashok, the star symbol has been got to reachable, Ashok. The leader is changed, right?
Yeah, because it was there before. Now it has been the both the manager, it has been moved to that. That doesn't make, because here see the manager status. We have just started the stop. That's the reason it has taken the start there. Because we have started just now the Docker, right? Pseudo system is the start Docker. So it has taken the start there. So you don't worry about that. Just see the manager status. Now, have you guys able to understand whatever we have seen up to now?
Yes, Ashok.
Okay, then I am giving you a task to do by yourself. Set up a 3-node cluster, means 3 EC2 machines.
Okay.
Create a service with 6 replicas. You can create Nginx service. Okay. And promote a worker to manager, and in one of the machine of the systemctl, run this command systemctl stop Docker on the manager, means whatever the first task you have taken, run it. Automatically the other one goes to the one, and check it out. Here, before doing this, here take the Docker node ls, print this one, and once you are done this, do this one. Same thing again. So you have to create a 3 node cluster, create a service with 6 replicas, promote a worker to the manager, and print the command Docker node ls and see who is exactly. Then stop the Docker on manager, and again check out the Docker node ls. Once you stopped here, you again start it, means because this will take a lot of time to shut it down. But once you started, means once you stopped it, do the Docker node ls on the other command, on the other worker who you are promoted to manager, and do the Docker node ls and start the system start ctl docker again on the other manager node, so that it works out. This is your homework. You can do it, you can try it, so that you will be able to understand how exactly works out. Have you guys understood, right?
Yes, Ashok.
And if you want, you can scale also, do the scaling also. Make the make the 6 to 10 when you are doing it, upscale it or downscale it. It's up to you. Now we will be talking about replicated versus what is replicated. Here, whenever we are doing it, if you have seen the service, whenever we are creating the service, docker service create, when we have created the docker service create command, what exactly we have given, replicas means we are replicating, means how many we want we are replicating. That is called replicated, means you can create as many as you want, in number, in any, in 2 instances, means we are having a 3 node instances, 3 node cluster. So in that we are giving 10, so it automatically distributes the 10 in between the 3. That is the reason we use replicated. But if you go to global, it is a service, only runs one task on one node, means one task to one machine only. If I run global, this will means docker service create command. Wait a minute. If I try to run again, it will throw the error because if I try to run, because already exists. Now here in the place of replicas, I will be using mode global, means here we are deciding every machine, means everything will be for a single machine, one task for one machine. The command would be sudo systemctl mode. Yeah, this was the one. Now let us run this command and see. If I run this, automatically each mode will be created, each task will be created. I am not giving anything, right? If you see docker service less, yeah, I have not mentioned any replicas, I have not mentioned anything, how many instances I needed, nothing. Automatically it has taken, okay, you are having 3 instances with you on your service, on your swarm. So I am gonna create one task on each one of the node. This was the global. Now if you stop anywhere, means if you stop, as we have seen, if you stop here, means if the docker is not available on one of the machine,
Ashok, sorry to interrupt, but the number of replicas we create, after creating it, none of the worker machines will be left idle, Ashok.
Sorry, I'm not able to get your question.
After creating the replicas, suppose we create 4 or 5 replicas, suppose three are assigned to the manager, and like it will be equally distributed to the other 2 workers. None of the worker will be left idle.
Are you talking about replica or global?
Replica, Ashok. Sorry.
Replica, the manager will assign the tasks, means the tasks will be assigned to worker, means how many instances. See, suppose you are having 3 machines. Now I have given 3. So automatically the manager decides, okay, the worker nodes means can get one each, and he may take one task. But if you have given 5, if you have given 5, the manager may take one and he may give the other 2 worker nodes 2. Or maybe he may take 2 and one worker will be having 1 and the other worker will be having 2. And if you provided 6, the manager may take 2 or may take 1, and he may give one worker node 3 and other worker node 2, maybe reverse 2 3. That way it's work out. He never keep any worker idle until unless if you have stopped that, if you have stopped the docker, if you have stopped the docker on that worker machine, then automatically the container is not present. So automatically the manager takes the task himself or maybe assign it to the other worker node.
Got it, Ashok.
Now if I stop here, if I stop this one here, if I stop that one here, see, now the global, see the global value.
3.
Now see the global value. Is it creating a new one? Is it creating a new one?
Oh no, Ashok, it is the same.
Why? Because it has been stopped. Why? Because it is not having anything here. The Docker has been stopped. So why will it create a global? Because the global is that one task per one node. If we are stopping the Docker, if we don't have the Docker at all in our EC2 instances, we are not having anything. So it considered in the Swarm cluster, we are having only two machines. So it will be giving the task only to the 2 instances, only to the 2 instances. If I do Docker PS here, it will be having 2 containers. One is Ubuntu and the other 2. This is Nginx because we have stopped. So the manager has been taken about a minute ago. Now, if I start this one, automatically, see, the global has been created. Now, for here to work it out, we have to stop one of the containers. So it takes the other one. This is the way how the global takes the tasks. This is the way how the global takes the tasks. Now, I think this is the one, right? As see, you have a, as we have given a use case where in an organization you have a SecOps team where they want to install antivirus, means as we are considering antivirus on every EC2 machine, whatever they were having on the Docker instances on the Docker. So they have given a task to mention each antivirus only on the containers, means on the EC2 instances. So that's the way the global works out. If you want to run only one particular task one particular task on every node, then we use global. So read the question out and answer me the answer.
Docker service LS.
Okay. What about you, Puneet?
Same. Puneet has answered that question, Ashok. Not me.
Okay. You, Ashok?
Same Ashok. Docker service LS.
Okay. I'm gonna print the command. You tell me the answer. Okay. Here you are you able to see the state? Docker service ls. What was the question? What was the question?
Get the state of tasks in a Swarm
Stated
cluster.
task. This one. To get status or state, Ashok. That is.
To get the state of the tasks. Now I'm gonna print another command. You tell me. You tell me.
State.
Where are you able to see the state?
Desired state, current state.
Okay, what was the question then?
To know the state of the Docker Swarm.
To state of the tasks in the swarm. So what should be the answer?
Docker service PS.
PS. Sorry.
See guys, the Docker service ls will show what are the service it is running. What is the service it is the name. It doesn't store the state of the task. The Docker service PS will show the state of the task. See the running, the shutdown, what exactly is happening. That it will be showing here. Any questions you have, you can ask me. Any questions? Any questions? Anything, whatever we have gone up to now, whatever we have done.
Once we practice, we'll able to get doubts issue. Definitely. Nothing as of now.
While creating the instances, Ashok,
Okay.
we will be creating like today we have created 3 instances. From that we have decided the manager.
We have decided means we have installed the Docker Swarm on it first. So if you have
Okay.
run in another instance, it would have been Docker Swarm.
Okay. While creating the instance in the like running state, can't we mention the manager thing?
I didn't get your question. Docker.
Ashok. Like after installing the Docker in all the 3 instances, and the
Okay.
Docker Swarm will be installed in the one instance.
See, Docker Swarm we don't install. The Docker it is already in the Docker engine. So we will initiate. We will just initiate the Docker Swarm. We will just initiate. We will initiate in any one of the instance on any one of the EC2 instance. That will be on that time itself will be considered as a manager node.
Okay.
If you want to have multiple managers, you can promote Docker node promote the other IP address of the EC2 instance automatically it will promote to the manager level, but the leader will be still be the one which you have first started the initiate one. In that case, if you stop or if you crash the system or anything, then the leadership will be shifted from that manager to the other EC2 instance, other node.
And once we run the manager Ashok,
Hmm.
we won't do much changes in the worker nodes, Ashok.
Worker nodes will not be able to do anything. They will be able to complete the tasks what they have been given. They will not be able to add any new Docker containers. They will not be able to delete the services which they are having. They can stop the Docker. We are directly stopping the Docker, not the Docker container. We are directly stopping the Docker. So that's the reason the Docker container is getting created in another EC2 instances. But we will not be able to stop the Docker also there. See, I think this is this one, right? I will not be able to perform any task on this worker machine. Any task. See,
Like this is where it comes into the picture that like number of users or traffics come. This will play the key role, Ashok. Like worker nodes.
just a minute. Okay, my suddenly network has gone. I don't know why. Yes, please tell me. You were asking, Yashwant, you were asking something.
Ashok, worker nodes, as you said yesterday, like the more number of traffic and users comes into the picture, this worker node will play key role, Ashok.
See, the manager will be the one assigning the task. See, you are working. If a project has to be brought, so who is going to bring the project? The manager will be bringing the project. Who is going to assign the tasks to the manager? Means suppose in a project I have been started a service. In that service, there are multiple internet traffic is coming, multiple persons are coming. So obviously I will be the one who will be giving the tasks. I will be the one I'm the manager. I will be giving the tasks to each one of you. You will not be able to actually go and take the task, right? The manager will be giving the task. The manager will be giving the task means suppose he sees that okay, now here I am having three tasks. I can give that to each one by one, and I can take one. Now if I have been means if you have been upscale, if you have been increase the service to 5 or 6, then he gives another two other worker nodes and he can take one. Or maybe he can give three one two. If the one worker can give it to three, the other worker can two, and he can take one. It will be replicated each one of thing to the worker nodes. But if you have stopped the total docker on that EC2 machine, and the EC2 machine is not available, not even available at that time, then it will reassign the task to some other worker or maybe to himself. If you have still doubt, let me know.
Got it, Ashok.
See, whatever the upscaling, whatever the traffic flow, because we are actually handling it now, we are having three replicas. But if you want to increase more, you can upscale it. It's up to you how many containers you need it. So let me delete this one. Now where were we? Okay, answer this question. Read out the question and tell me the answer. Come on, guys.
Use replicated service mode, Ashok.
Read the question very carefully and tell me the answer.
Created a container can do this automatically. Ashok, is it use global service mode because they have mentioned it, which can do this automatically.
Use push all service mode, Ashok.
See what they exactly did. Puneet is right, but the way he was thinking was a little wrong. See, they what they have asked. The container should be part of all the servers. The container should be means in every server that it should be present. In every server, it should be present. Because with the global only, you can be having the node, the service in each of the node. In replica, as I mentioned, there is a chance they may give it, they may not give it. It depends on the leader. It depends on the manager node, because he will be deciding whether to go or not. But in the global, everything, because it has been mentioned, the container should be the part of all the servers, means every server, every node should be having that container. So the answer is global service mode. Automatically means automatically, if you give replica also, automatically it will be created, Punit. If you give replica 3, replica 4, automatically if you stop one of the service, one of the things, automatically it will take care of it. It will be created another one more service. It's not like that we are manually creating. We are not actually created anything manually now. We are just given the service name, automatically it has taken. You what the way you have said the answer is right, but the way you are thinking is a little away from the main topic.
Okay. Got it,
Now,
Ashok.
whatever we have discussed up to now, whatever we have discussed, availability is worked out, right? Availability
Scalability.
initially we are stopping it, it is going, and scalability we can likely able to increase the uh, what we call increase the nodes, increase the service automatically. We are able to upscale and downscale.
Downscale.
And what was the other issue? Multi-node challenge, where we were able to run multiple containers on different instances. On 3 instances, we are running 3 containers. We can run 10 also. The multi-node challenge is also been able to handle. And the last one was the
Deployment challenge.
deployment. Without having downtime, I have to modify it. How? Now suppose how this can be done is that now I have 6 replicas. Now I am having a 6 replicas. Now having six replicas. Now I'm in a production application. Now I want to change the V1 to V2, the version V1 to V2. How exactly I'm gonna do it? This will be done through rolling update. What exactly how it works out is the rolling update first takes means first takes these two services, these two containers, and changes the version to V2. When they are down and they are changing it to V2, the load will be balanced by these four services, these four containers. Once the V2 are back, then the other two will be modified. At that time, these two and the top two services will be handling the load. Once they are back, the next two will be modified. At that time, the top four will be handling the node. And once they are the other two, last two are up, so the total load will be handled by the sixth. And now the version has been changed to V2. This is the way it works out. Let me show you. Now I don't have any service, so let me do it. How you are gonna update the service? I'm gonna first create as a replica, which is a manager. Let me here itself. Okay. Now I am having 6 services. Now I want to update. Now I want to update the containers from version V1 to V2. Okay. Now here, Docker service update parallelism means in a parallel way. In a parallel way, I'm updating 2 at a time. See, it's up to you. You can go 3, you can go 4 also. But if you want to have that load, we are having only 6, so it updates only 2. This was the reason we have given update parallelism as 2. And what is the delay? Means what is the delay between? Means once it has been updated, how many time it should take? 20 seconds. In the 20 seconds. And what is the image? Means we are using Nginx and I want to update it to Nginx 1.8 Alpine. And what is the service name you are having? Now, if you run this command, automatically it will be taking care. It will be showing how exactly this will work out. See, see clearly. Once 6 has been starting running, then it will go to the 3 by 3 and 4. Then after that, it will go 5 to 6. At the meanwhile, the 3, 4, 5, 6 will be handling the load. Now, see the screen, you will be able to understand. Now see, it is started preparing on the next 2 things. Now they are running. Now it is waiting for the time of 20 seconds and delaying it, and then it is starting again. See, now it's got started. Now all the images, now all the containers has been updated to service 2. This is the way we do it. This is the way we update. We do see before that what was the image? It was just Nginx. Now the image changed to image Nginx 1.8
1.8.
Alpine.
1.8 is.
This is called rolling update. This is called rolling update where we do it. So replacing running Docker image version with a new version. No downtime. We have stopped anything. No, automatically it got updated. We just ran the parallelism in parallelly when the production application for anything, if we are running it, if we are doing it, how exactly it works out, how exactly without stopping the image, without stopping anything, we are working on it, we are running on it. So if they are given example, if 4 containers running first, we can replace 2 containers with new version. Once deployed, we can replace the remaining 2. The same way we have just done on the 6 by 2222. So our total homework will be the one along with it, create a global service also, create a global service also, try that one and try rolling update also, so that you will be able to understand what exactly you have done. Like the same way they have mentioned, you can create a one replica and you can upscale it to 4, and you can start using the update parallelism and it can work out. This is rolling update, and this is the way how we deploy any application, any container, anything on EC2 instances using rolling update, using Docker Swarm. Any questions, guys?
No, sure. We'll practice.
You have to.
Yes, yes, yes.
The orchestration is very important, and I think the PPT explains you maximum things, because uh, whatever you needed, whatever you want to work it out, it is already there.
Today I'll upload this PPT, Ashok.
Yeah, I will upload. I think yesterday I've added you to a new.
Yes.
Only
Task.
18 slides, Ashok, in that.
I will update this one. I will upload, not right just now. Upload. I am saying uh, to the new drive folder. I think I have updated to you, so you can just go there and you can take the PPT and everything. So do the task and try the assignment, and tomorrow we will discuss, and tomorrow we will be discussing about the overlay network, and once we started in Docker, that what are the other two networks we are going to discuss, and why the Docker compose, the advantage I think already has been discussed. So what is pending here? Basic features is done. Docker compose versus from applying application we have done. Its architecture is done. Deploying an application is also done. Basic features of form is also done. Docker compose versus form. I think we need to discuss this one.
Architecture also, sure.
We have discussed the architecture yesterday itself, right? What we have told me this.
The back slide, Ashok. 15th slide.
It's just a image. This is not anything. I've just mentioned a life cycle. This is not actually the architecture. I'm saying you just to make sure how exactly it works out, how exactly it goes on the life cycle. See, it's just that you are pulling an image from the Docker Hub and you are created that image, means the, and it, you have started that image. If you have run, it is in the start stage, means the Docker has been created. The pull command, what you have taken the image, it is in created. So, and if you started it, if you started, means it is in the running state. And if you stop or start, or if you pause or unpause, and whatever you have done, you are in the running phase only. Once you stop that, once you stop, or once your work is done, whatever you want to do, and it has been gone to dead, means your work is completed and you're not going to use that image. So that means the Docker has been dead at that time itself. It's just a life cycle. I've just provided you to show you how exactly that image goes on. This is not actually architecture. This is a life cycle of the container. It is create, start, and dead. It's a what we have three phases: create, starting phase, running phase, and deletion phase. Once your work is done, you will obviously delete the Docker, right? Delete the Docker images, or maybe delete the Docker containers once your work is done. This is just an image to understand how exactly it works out. And this is the orchestration tool, as we mentioned. This is the way the container, means Docker Swarm, Kubernetes, AWS, whatever you have, you will take it, and whatever the availability you are taking, you will be running on the application, multiple environment. The same wordings which we have discussed, I have mentioned everything, is been just in an image. That's it.
Got it, Ashok.
And there is only one thing: the overlay network and everything is pending. So once this is done, I think I have to explain it, logging and everything. Any more questions, guys?
We'll complete the task and come up, Ashok, with any questions if there are.
Yeah, sure. I'm gonna upload a PPT today itself. So try it and try to complete the assignment too.
Okay, Ashok, sure.
Let me stop all the tasks, because otherwise. Okay, guys. Have a nice day. Stay safe. We'll meet you tomorrow.
Sure,
Yeah,
Ashok.
sure.